Good afternoon to you all, respected panel members, lecturers, and all my friends. I'm Srung Wangmu, taking this opportunity to represent group number 12. We are a member of three, Sonam Churin and Sangye Yenten, under the guidance of Mr. Yishi Jamso. We also have Mr. Yenten Jamso from Gyalpo College of Information and Technology as our external guide, who has completed his master's study on machine learning. These are the outline for today's presentation. To kickstart with the problem statement, there are varieties of foods available all over the world, some of which are well known internationally and others which are known in a specific area. Likewise, Bhutan has a diverse food culture with just a few food items familiar to foreigners, but some food items are new to foreigners as well as people from various districts within Bhutan. With the growing number of people using technologies, it has contributed to the rise in growing popularity of image recognition in deep learning. Therefore, to familiarize the names of Bhutanese food with the help of training technology, this project was started with an aim to develop a Bhutanese food recognition system using CNN, proceeding with the incorporation of model in web application. What really motivated us to take this project was, over the years, deep learning has gained its popularity in the field of image recognition. With the keen interest to learn more about the training technology, we started exploring on AI. Since we are new to this field of research, we decided to start small. Therefore, we wanted to address a problem concerning Bhutanese society. According to the paper written in the year 2019, food recognition using image recognition is an important activity that can assist people in knowing the names of various food. And many researchers have conducted various studies on various types of foods available all over the world, but none have been conducted on Bhutanese food, despite the fact that Bhutan has diverse cuisine. Therefore, keeping these points in mind, this project was started. After studying related works on image recognition, it was found that one of the most important components of image recognition is dataset. To the best of our knowledge, there is no publicly available dataset for Bhutanese food, which further motivated us to take this project. The objectives that are set in order to achieve project's aim are to conduct literature review and study related works, to build a dataset for Bhutanese food recognition, to develop a naming recognition system for Bhutanese food items, and to integrate Bhutanese food recognition model to a web application. This is the overall project methodology, and this is the system architecture that we have defined for the project. The Bhutanese food recognition model is developed using CNN, that is convolutional neural network. One must be wondering why we choose this algorithm in order to develop Bhutanese food recognition system. The main reason is because it is the state-of-art approach in deep learning and used mainly for image recognition, segmentation, speech recognition, etc. Traditional methods such as SVM, MLP can also be used for image recognition, but the main drawbacks with traditional method is that features need to be handcrafted feature, which means the developer has to provide the feature that they want to extract, whereas CNN automatically learns features from the image themselves. So this is the main reason for choosing CNN for Bhutanese food recognition system. CNN are usually made up of three different layers as shown in the figure, namely input layer, convolutional layer, and output layer. The training, validation, and testing dataset are fed to the model via input layer. We usually have an RGB image with three colors, red, blue, and green, as our input image to the input layer. The convolutional layer consists of three sequential and repetitive layers that are convolutional layers, pooling layers, and fully connected layers. The convolutional layers apply a range of convolutional filters to a given input image. These layers typically add an activation function to the outputs in order to integrate non-linearity into the model. The convolutional operation's idea is to identify high-level traits from a source image like ages, colors, etc. The performance of the deep learning model as well as its accuracy and reliability are determined by activation function. The pooling layers are the second type of layer in CNN architecture, which are responsible for downsampling the features generated by convolutional layers to reduce the feature map size and speed up processing time. There are several pooling operations that can be used in pooling layers, such as maximum pooling, average pooling, and minimum pooling. The pooled feature map undergoes flattening, whereby the feature map is exactly flattened to one dimension and forwarded into a neural network known as fully connected layer. Fully connected layer performs classification on the extracted feature after downsampling. The fully connected layer connects the neurons of one layer to the neurons of another layer. The model uses softmax classification algorithm to differentiate between dominant and other low-level characteristics in the input images throughout a series of epochs. One of the most important aspects of this project is to come up with a Bhutanese food dataset, since there is no publicly available dataset for Bhutanese food. So for this, the dataset of 5 types of Bhutanese food consisting of grayscale and RGB image were collected. The 5 classes that have been identified are Dengo, Emadate, Hente, Kule, and Puta. In each of the classes, there are 1,000 images summing up to 5,000 food images in the dataset, which was further divided into training, validation, and testing set. For the preparation of the Bhutanese food dataset, raw images were collected along with some videos of the food. The collection of the raw images was done by taking pictures of the food and through crowdsourcing. Since food images that was collected through crowdsourcing was insufficient to obtain 1,000 images for each of the classes, we had to consider additional option in order to complete the dataset on time. So a web scraper technique was used. Web scraper is a method of extracting information from websites. There are various approaches for scraping images from Google. In order to scrap Bhutanese food, we have used urlib and Beautiful Soup libraries. Urlib is a Python module that allows to access and interact with websites with their URL. One of the challenges that we faced was that while scraping food images, all the images related to keyword was also being scrapped, and we had to delete it one by one, which was quite time consuming. As some of the food images, such as Puta and Kule, were difficult to get, therefore short videos of the food were recorded and multiple frames was extracted from the recorded videos. Depending on the length of the video in seconds and frame rate, multiple frame was extracted. For example, we have 10-second video, which was taken at 30 FPS. The total number of frames that was extracted is 10 times 30, which gives us 300 frames. All the 300 frame was further segmented based on relevancy. The figure given shows the extracted frames of 10-second video of Kule. Since the food images were gathered from a variety of sources, their format, resolution, and quality differed. Moreover, the number of collected images were not sufficient to build a robust recognition system. As a result, data augmentation was performed on collected food images in order to increase the size of the dataset and to add a variety in the dataset. Data augmentation refers to a set of techniques for increasing the size and performance of training dataset in order to build better deep learning model. To produce new images from an image, data augmentation such as flip, rotation, contrast, brightness, sharpness, and grayscale were applied to each of the augmented images to minimize image similarity and to increase the size of the dataset. The figure on the right shows the artificially produced images. For the preparation of the dataset, a Python virtual environment has been created. Python virtual environment allows to create an isolated working environment for Python application whereby the required Python libraries and packages are all installed in the environment using pip installer instead of installing in the local PC, thus reducing the usage of desktop storage. Visual Studio Development IDE, Python version 3.9.2 and OpenStreetView version 4.5.1 has been utilized to code the program for processing the dataset that was collected. And this is the finalized dataset for the project. There are 5 classes. Each classes consist of 1,000 food images. And as a whole, the dataset consists of 5,000 food images. Regarding the development of the model was developed from the scratch on Google Colab using Keras libraries. Google Colab is an online notebook which allows us to write and execute Python code, and it also provides free access to GPUs. One of the crucial initial steps for developing the model is to identify the number of convolutional layers. There is no fixed rule stating that the number of layers that one has to take for a model, which initially confused us regarding number of layers we have to take. With trial and error method, we started off with 7 layers. Various experiment was carried out based on most widely used optimizer. Optimizer is one of the factors that determines the efficiency of the model. According to the paper written by the author Pujari, HGD, ADAM, and RMS prop are the most widely used optimizer. We carried out an experiment where we have considered these 3 optimizers. For all the listed optimizers, the model was trained considering different number of layers. For example, using ADAM optimizer, the model was trained 3 times, but with different number of layers. One of the challenges that we faced was that constant and strong internet connection was required during the training and testing of the model, which was not always possible with the college Wi-Fi. Therefore, the net constantly got disconnected, whereby we had hard time keeping track of the training time. Along with the other parameters, the time taken to train the model, training and validation accuracy was noted in the form of table. From the table, the model using ADAM and RMS optimizer with 7 and 9 numbers of convolutional layers performed quite well, and the training and validation accuracy were quite impressive. For both the optimizer, there was a significant gap between the training and validation loss. It can be inferred that the model is a good fit, but it may also be overfit. Overfitting is a modeling error which usually occurs when a neural network is trained to the point that it begins to memorize rather than generalize. The model with accountable loss and high validation accuracy will further improve to minimize the loss suffered by those models by adding a dropout layer and also by using callbacks. Dropout, it is a technique that removes some of the neurons during the training phase of certain set of neurons, which is randomly chosen. The models were added with two dropout layers, one between the fully connected layers and the other between the output layer. From the graph, we can infer that the model using Adam optimizer with 7 convolutional layers with dropout had a decrease in validation accuracy, which indicates that the dropout wasn't necessary for the model with those parameters. On the other hand, a model using Adam optimizer with 9 convolutional layers showed a fine increase in validation accuracy and depletion in loss using the dropout layers. Similarly, for RMS prop optimizer, the model with 9 convolutional layers showed an increase in both the accuracy and the model losses. Now, in order to select the required model for the Bhutanese food recognition system, we evaluated various models, and the best performing model with higher validation accuracy and less loss were selected. These candidate models were trained for 20 epochs with batch size of 50 using early stopping and learning rate reduction callbacks. The graphs on the right side represents the model accuracy and loss for the model with which consists of 7 convolutional layers with input size 224 and using Adam optimizer. The early stopping was executed at 7th epoch. The training loss was 0.0199 and validation loss 0.4986, which was least of the best performing models. There is a sizable difference between training and validation losses. The gap between training and validation loss is narrow and has already approached a stable point, indicating that the model is a good fit. After the development of the model, it was saved in H5 format, and this is the model summary for the selected model. To better visualize the performance of the selected model, the confusion matrix and classification report were constructed on the test dataset. These matrices also aid in visualizing the true and false assumption made by the model. The testing accuracy of the model was 94.20, which is quite valid and good model for the correct prediction of 5 specified Bhutanese food. After the completion of the model, it was incorporated with the web application to test the model. The web application was developed using Django framework, Bootstrap, Visual IDE, and Python version 3.8.1. The prototype for the web application is shown on the right. To further comprehend on the topic, short demonstration will be played in a while, but before that, let me summarize the whole presentation. Bhutanese food recognition system is a system.
You got 3 minutes.
Okay, ma'am. Bhutanese food recognition system is a system designed to identify 5 different types of Bhutanese food. It was constructed with a convolutional neural network, which requires a large dataset, since dataset is crucial in any image processing application. Throughout the project, various research on related works were carried out to gain a better understanding of the project. This project began with the aim of developing a Bhutanese food recognition model using CNN, followed by the incorporation of model into a web application built with the Django framework. Furthermore, this project was started in order to create a Bhutanese food dataset, which currently does not exist. The model for Bhutanese food recognition system focuses only on 5 types of Bhutanese food. However, it is not limited to those. The model's performance can be enhanced by expanding the dataset size by adding more food classes and collecting more food images, since in Bhutan there are still a lot of foods and their generic categories which can be studied. Lastly, this project will serve as a starting point for those who wish to do extensive research on Bhutanese food recognition. Let me show you the short demo.
This is the simple, responsive web application we have developed in order to integrate our Bhutanese food recognition model. So, to explain about the working of our web application, we have created a form inside the HTML file, which helps us in choosing, uploading, and classifying the names of the images. Firstly, the Choose File button allows us to select an image from the device we are using. So, let me first select an image of Hente. And then when we click on the Upload button, the selected image gets uploaded and displayed to the users on the web. Then upon clicking on the Predict button, the input image is fed to the model and then it will predict the level for us, and accordingly the predicted level is displayed here, saying the name of the food is Hente. Okay, now let me try to choose an image from another class. So here, let me choose from Emadasi. And then, as expected, the name of the food is Emadasi. Then we have also created a page where we have explained about the need of Bhutanese food recognition system and also about our team.
That's all for the presentation, sir. Thank you.